afternoon to all of you. Myself, Dr. Jaishree Jain, Associate Professor in Ajay Kumar Gini College, Ghaziabad from CSE Department. So today we will learn decision tree techniques, that is supervised machine learning algorithm, in which we will learn how can we classify our data using the decision tree approach, and what are the benefits or pros and cons of these techniques. So firstly, we have to understand what is decision tree and how it works. So agenda of this lecture will be basically what is a decision tree and the appropriate problem for D trees, information gain and entropy, issues with decision tree, overfitting, pruning, and demo. So we can say decision tree is a supervised machine learning technique that can be used for both classification and regression problems, but mostly it is preferred for classification problem. So we already know what is supervised learning. Supervised means our data set have been labeled, and we already know the classes label, and so that we can easily find out the label, the category of the data, and we can now then use the classification technique. So this is also the supervised learning, means our data will be labeled and categorized, and then we have to use the decision tree technique to classify our data and to maintain the find out the target of the data. So it is a tree structured classifier. So already we know this is the decision tree. So in tree we already know we have some node, intermediate node, those are called as a decision node, and we have the leaf node where we get the class of the data. So final leaf node will tell us the final class where data will belong, and the root node will also the decision node. So how can we decide which one will be the root node? If we have 3 features in our data set or 4 features, then among those 4 features, which will be the root node, then we have to use the algorithm of ID3, that is a decision tree algorithm that will calculate the entropy or information gain of the data features or attributes, and the attribute which have the highest information gain, that will be the root node of the data set. So we have to learn how we calculate, what is the calculation and what are the steps, how can we calculate the information gain, and how can we identify the root node. So this is all about the nodes. Now next is branches. So branches are the decision rules. Rules means branches means branch have the value of the node. Like if we have age as a root node, then at the branch that will contain the kind of age like 30 to 40 or 40 to 50 or greater than 60. So here we have the data value, attribute value. So that is the branches that represent the decision rule, and each leaf node represent the outcome. So outcome means what will be the outcome of the problem, that is a class, means we have to find out what is the class of the particular feature, class of particular data set, whether it is yes class, whether it belong to the no class, or whether it belong to pass or fail class. So depend on the data set. So it is graphical representation for getting all the possible solution of a problem, and decision is based on the given condition. So we have to just have the data set, and we will find out the gain and entropy of the each and every feature, and we will find out the root node. After that we will again calculate the remaining feature information gain and make the intermediate node, and after at the last we will get the final class or the outcome at the leaf node. So what are the terminology here? First is the root node. Root node means whether the decision tree start. Root node means where the decision tree start, and it represents the entire data set. Actually the root node contain the entire data set value. By root node we can traverse the entire data set. Next is leaf node. Leaf node is the final outcome node where we get the final decision, and tree cannot be segregated further. Splitting is the process by dividing the decision node or root node into the sub node, where we connect root node with the branches, and then the child node will connect with the root node. So splitting means we are splitting our root node into the sub node. Next is the branches. So branch means the tree formed by splitting the tree. When we split the root node, it will connect the sub node or root node with the branch, that is the edges or branch. Next is pruning. Pruning is the process of removing the unwanted branches from the tree. Basically, where pruning is used, when we classify our data using decision tree and we reach to the leaf node, then it is over parameterized and the problem of overfitting will occur. So we will try to remove the overfitting problem with the help of pruning. Pruning means we are cutting the edges of the subtree. So we will cut the subtree part from the whole tree and we will try to minimize the overfitting problem, and we decide after cutting the edge we will make that node as a leaf node. Next is parent or child node. So parent or child node means that is the sub node of the any parent node. So here is the example. If here is the example means we have salary that is between $50,000 to $80,000, and we can classify, we can segregate it like if it is yes, then we will follow this subtree, and it is no, then decline the offer. This is the leaf node. And if it is yes, then we can make the another node like office near to home. Office near to home, yes, means provide cab facility, yes, accepted the offer. So this is the example of decision tree. How can we grow our decision tree, and each and every feature get utilized here, like salary feature is there, location, cab, and at the end we will get accepted and decline. There are two classes, so we can find out the result. So this is the process. How can we, means step 1 means begin the tree with the root node, we already learned, and find the best attribute in the data set with the help of attribute selection measure. So what is this technique? Attribute selection measure, where we use the ID3 algorithm. So ID3 algorithm will be used to find out the entropy and information gain in the data set. When we get the highest information gain of any feature, then we will make that feature or attribute as a root node. Then third is divide the S into the subset that contain possible value for the best attribute. So when we classify further it in the number of values, so we will branch out, subdivide this node into the subnode, and we will get further subnode here, and here we get the decision. So step 4, generate the decision tree node. This is decision tree node which contain best attribute, and recursively make the new decision tree using subset of the data set created. So this is a recursive process. So further, firstly we make the root node having high information gain, then again we get the calculate information gain and make the decision node, and further we will repeat this task until all the feature will be utilized, and finally we will get the leaf node. Final node will be the leaf node. So this is the process, and now we will move forward again for calculating the mathematical calculation for calculating the information gain for finding out the root node. So first is attribute selection measure. So in attribute selection measure, how we will just find out how to select the best attribute for the root node, and for that we have two popular technique, information gain and Gini index. So generally main popular algorithm is information gain, and we can also calculate the Gini index. So what is information gain? With measurement of the changes in the entropy after segmentation of data set based on the attribute. So we will, if we have like we have weather forecasting, we have the weather like sunny, rainy, and we have humidity, wind speed. So we have different attribute, and we have to decide whether Tom will play outside to play tennis or not. So we have to check the weather condition. So for that we have to build up the decision tree. So we have to just find out whether I want to make the root node as a humidity is the main feature, or wind speed is the main feature, or weather is the main feature. So we calculate information gain of each and every attribute. So this information gain is the change of entropy. So firstly we will calculate the entropy of each and every attribute, then we will finally calculate the gain of subtree of the after calculating the entropy, this has a formula, we will calculate the gain. So it calculate how much information a feature provide about the class, means importance of feature. So information gain high means that feature is very important to calculate, to classify the class. So according to the value of information gain, we split the node and build the decision tree, and this algorithm always try to maximize the information gain. So this is the formula of information gain, means entropy minus weighted average and into entropy of each and every feature. So this is the entropy of entire data set, and this is the entropy of each feature, individual feature entropy, and this is the weighted average of number of value containing that attribute contain number of values. So this is the weighted average here. So this is the formula, and entropy we all know that is calculate the impurity in any given attribute, means randomness. It calculate the degree of randomness, means that is the entropy. And next is Gini Index. Gini Index also is measure of impurity or purity used while creating the decision tree using CART. This use the CART algorithm, classification and regression tree algorithm. So an attribute with low Gini Index should preferred as compared to the high Gini Index. So here this is opposite, which the attribute having low Gini Index will be chosen as a root node. So it only create the binary split, and CART algorithm use the Gini Index. So we have the formula of Gini Index here, 1 minus summation P of P square, actually P means probability, summation of J P square. So this is the formula of Gini Index. So next we move to ID3 algorithm, that is iterative dichotomizer 3. This is a full form of ID3. So what is basic idea? This is invented by Jaishree in 1975, and it is used to generate the decision tree from the given data set by employing the top-down greedy search. So actually decision tree approach is top-down approach, and so where we divide our data set into the form of tree, and resulting tree is used to classify the future samples. So we calculate the entropy of each attribute, split the set into the subset using the attribute for which entropy is minimum or information gain is maximum. So this is a process where entropy should be, it is a proportional, entropy will be minimum and information gain should be maximum. So inversely proportional is there, and make a decision node that contain that attribute, recurs on subset using remaining attribute. So this is a process. So what is entropy formula? Entropy is Pi log Pi. I means number of attribute. So we have this is a formula where we calculate the entropy of each and every node. S is the node and this is the probability. So Pi is the proportional of S belonging to class I, and summation is over the total outcome, and log is base 2. So for example, if S is a collection of 14 examples, so we have taken example of 14 sample with 9 yes and 5 no. We have total 9 yes class and 5 belonging to the no class. So entropy of entire data set will be minus Pi, means for positive case 9 by 14 log to 9 by 14. This is for positive case, and this is for negative case 5 by 14. Out of 14, 5 is no. So 5 by 14 log 5 by 14. So we just, this is minus and this is also minus. So this will get added and we will get the value, that is 0.94. So entropy will be 0.94 for this case. So this is how we calculate. So entropy means if entropy is 0 for all the member S belonging to the same class. If all the values in the data set belonging to the yes class, then entropy automatically becomes 0. And if entropy is 1 when we contain equal number of positive and negative example, means if we have 50% positive, 50% negative, so entropy will be 1. And entropy lie will be 0 between 0 and 1 because it is a probability and it is a collection if the collection contain unequal positive and negative example. So this is the how entropy we can directly calculate. If we get this condition or this condition, we will put 0 or 1, and here we calculate the value. So that next is information gain. So what is the information gain for entire? This is a formula. So gain of S comma A means attribute. So entropy of S, this is the entire data set entropy, and this is the weighted value, and this is the entropy of subtree, entropy of that feature actually, entropy of that attribute. So SV is what? Subset of S for which attribute A has the value V. V means class. We belong to class. Like we have two class, yes or no. So V is belonging to yes or no. So we have two subsets, one for yes and one for no. So we will calculate how much value belonging to yes class and how much value belonging to no class. And S of V is the number of elements in S of V, means number of element belonging to yes class and total number of elements. So SV divided by S. So first the entropy of entire data set is calculated. Then data set is split on different attribute, means we have different decision tree. Then entropy for each branch is calculated, and then it is added proportionally, means yes case plus no case, to get the entropy for the split, and resulting entropy is subtracted from the entropy before the split. So this is the formula where we subtract this sub entropy from the entire entropy set, and the result is the information gain or decrease in entropy. When we subtract it, then entropy will get decrease and we will get the information gain, and the attribute that yield the largest information gain, that is chosen as the precision node. So here we can take the example. Here we have these features like age, income, student, credit rating, and buy computer. So we have total 14 attribute here, 14 values here, sorry. And so firstly we will calculate the entropy. Here we get 9 yes is there, and 4 no is 5 no is there. So we will get entropy of entire data set here, and then we will select the attribute like age having 3 value, less than 30, 31 to 40, and greater than 40. So in less than 30 we have 2 yes, 3 no. In 31 to 40 we have 4 yes or 0 no, and in age greater than 40 we have 3 yes and 2 no. So we will calculate the entropy of age attribute here. So total yes is 5 by 14. So SV upon S 5 by 14. We are calculating yes case into entropy of this feature, minus 2 by 5 upon 2 log 2 by 5, and here we have 3 by 5 log 2 3 by 5 plus next is this. So this is 4 by 14, 4 out of 14 into all the attribute, all the value belonging to only yes class. So entropy will become 0, and next is same 5 by 14. Next minus 3 by 5 log 2 3 by 5 and minus 2 by 5 log 2 2 by 5. So calculating this value we get this 0.6935. Subtract this will entire entropy 0.94 minus 0.6935. We will get 0.2465. Similarly, we will get the entropy or information gain of income attribute. So for income, we will also calculate this way, and this is the entropy of income data, feature, and we will get here 0.91. So subtract it from entire entropy 0.0292. Next is student. So similar way we will get the gain of student, and for credit rating. So finally we get information gain of age, income, student, and credit rating. So which one will be the highest? Age will be the highest. So age will become the root node, and age have 3 value, less than equal to 30, 31 to 40, and greater than 40. So we have 3 subtree here. So here in 31 to 40, this one be the subtable. This one will be the subtable in case of less than 30, and this will be the subtable for greater than 40. So here this is a disease. Now again we have to calculate the entropy for